You have probably effects of static electricity. If you walk around on a carpeted floor, then grab a metal doorknob, you might get a quick shock. That is static electricity in action. Most objects, like a table, a chair, and a person, are electrically neutral. This means that they have an equal number of positive and negative charges. Objects are made up of atoms, with the nucleus at the center, composed of positive protons and neutral neutrons, and a cloud of electrons surrounding the nucleus. That means that the cloud of electrons sits on the surface of every object. When objects are rubbed against each other, some objects are prone to lose some electrons, while other objects are prone to gain electrons. This buildup of excess charge is what is called static electricity. The static charge buildup is temporary. The excess charge is usually lost through a discharge, shock, particularly when the object is near a conductor, like a metal doorknob. There are different ways charge can be separated from a neutral object: by heat, pyroelectric effect; by pressure, piezoelectric effect; by charge induction, electrostatic induction; and the most common way, by friction, or triboelectric effect. In this lesson, we will focus on the most common way to build up charge, the triboelectric effect. The triboelectric effect is a simple process in which an object becomes electrically charged by rubbing against another object. When objects rub against each other, some objects are more likely to lose electrons, while others are more likely to gain electrons. This table lists a variety of materials listed as positive, lose electrons, or negative, gain electrons. How does this table work? If two of these objects are rubbed against each other, the object higher on the list will lose electrons, and the one lower on the list will gain electrons. So how do you prevent or get rid of static electricity? You may be familiar with an everyday task that gets rid of static electricity. When you wash clothes, you put in fabric softener. The fabric softener reduces or completely removes static cling from your clothes. When clothes are in the dryer, they rub up against each other, and the friction due to this contact causes a buildup of electrons on the clothes, giving the clothes a charge. If you've ever forgotten to use fabric softener, you know that the clothes would stick to each other and even discharge, give you a shock, when you put them on. What the fabric softener does is coat the clothes with a thin layer of chemicals that makes the clothes smoother, reducing friction, preventing the buildup of charge on the clothes. Humidity is also a remedy for static buildup. Humidity makes the air conductive, allowing the excess charge to move from the object to the air. You may notice that you are more likely to get a static shock in the winter than in the summer. This is mainly because summer air is more humid and winter air is drier in many regions. The absence of moisture in the air causes a static buildup. Removing static is important for microelectronic devices, which is why they are always packaged in conductive bags. In these bags, the charge is allowed to move away from the device. Let's cover some facts about static electricity. Lightning is one of the most dramatic examples of static electricity. During a storm, the wind turbulence causes air to move up and down quickly. This movement of air is just what is needed to cause a charge separation in the clouds and on the ground. The top of the cloud becomes positively charged, as does the ground. The bottom of the cloud becomes negatively charged. This figure depicts the charging that occurs during a storm. This charge separation causes discharges within the cloud in the form of lightning, as you may have noticed during thunderstorms. The right conditions can cause a discharge between the bottom of the cloud and the ground. This is usually what we see during a thunderstorm. Static electricity is also used in laser printing. The drum of the printer is positively charged, the paper is negatively charged, and the charges attract each other when they come in contact with each other, forcing the positively charged toner to bind to the negatively charged paper. The heat inside the printer ensures that the ink stays on the paper. Colored printing uses the same process, binding layers of different colored ink onto the negatively charged paper. The same principle is used in painting cars. The car is given a negative charge in order to bind with the positively charged paint. The result is an even distribution of paint that binds better with the car. A fun example of static electricity is the Van de Graaff machine. A Van de Graaff generator contains a conveyor belt and a metal brush. In simple terms, the brush charges the conveyor belt, and the belt transports the excess charges to the dome. The inside of a Van de Graaff machine is shown here. The charge that accumulates on the dome is just waiting to discharge. Putting your hand on the dome can cause the excess charge to flow through you and make your hair stand up on its ends. This hair-raising experience results because your hair fibers become charged with the same type of charge. We know that like charges will repel, and since all of your hair fibers have the same charge, they will repel in the only way they can. Static electricity is the buildup of charge on a material due to frictional contact between objects. Triboelectricity determines which material becomes positively charged or negatively charged as a result of this frictional contact. The excess charge does not last very long. Something as simple as touching a conducting material will discharge the excess charges. This is the reason why you sometimes get a shock when you touch your car or another person. Humidity is also a cure against static electricity. The water molecules, which are conductors, can prevent the buildup of excess charge on an object. The most dramatic example of static discharge is a lightning strike.